In 8.5, we move to rational functions, which is simply a polynomial divided by a polynomial. And we've already looked at these before. So the number one thing that we want to do is we want to factor the top and factor the bottom first. Okay, always when we're looking at functions like this, we want to factor the top, factor the bottom, and then I'll tell you what each of these pieces means and how we can apply them. So the top piece, x squared minus 4, is x plus 2 times x minus 2. Okay, that's a difference of squares. This one, we factor normally what multiplies to negative 8 but adds to negative 2. I believe if I've done math correctly, that's negative 4 and positive 2. So if I multiply these two, that'd be positive 2x, negative 4x, give me negative 2x, 2 and 4 is negative 8. Okay, so now I have that. So remember, whenever we looked at these before, what did we do? We said we could simplify by taking pieces out that are the same. Great. Now what are we left with? Well, this over this. X minus 2 over x minus 4. Now, what we didn't talk about before is how this canceling piece and what's left affect our graph. Okay, so when things cancel, when there's a common factor in the top and the bottom, this is a hole in our domain. Okay, so our domain for this function is going to be a little bit different than what we've looked at in the past. Okay, the hole is going to appear when there's common factors. So a hole in our domain. So this function right here, there's a hole in the domain at x equals what? How do we find x equal to? We set the piece equal to 0. So that would be x equals negative 2. X equals negative 2 because x plus 2 equals 0 would give me this. Okay, so remember, common factors on the numerator and denominator give us holes. The second piece we want to talk about is vertical asymptote. Okay, vertical asymptote is the place on the graph, if I drew something like this. Okay, if I drew something like this, it's the place where this side and this side do not touch the line. Okay, vertical asymptote can never be crossed. Why? Because vertical asymptote is when the denominator equals 0. That means our vertical asymptote is at x equal 4. X equal 4, because I set the denominator equal to 0. And what happens when our denominator is 0? It's undefined. So in other words, if this x equal 4 would be this undefined line that neither line can touch. Why can't they touch it? It's undefined. Okay, now there's one last thing that we want to look for, and that's horizontal asymptote. Horizontal asymptote. Okay, horizontal asymptote is a little bit more difficult. It has 3 possibilities, and all 3 of these possibilities deal with degree. Okay, they all deal with degree. So we have the first possibility, if the degree of the top and the bottom are the same. So if the degree of the top and the bottom are the same, then our horizontal asymptote is y equals that ratio, whatever the numbers are in front of x squared and x squared in this case. So in this case, it would be y equal 1, because 1 over 1 is 1. Okay, and we'll do another example in a second where the degree is not 1. Okay, that's one option. If the top and the bottom are the same, it's the ratio in front. What if the top is a bigger degree than the bottom? Okay, then this means there is no horizontal asymptote. If the top has a bigger power, like x cubed, and the bottom was x squared, there's no horizontal asymptote. If the top is bigger, no HA. And the last option would be flip-flop. If the bottom was, sorry, I didn't mean to put bottom, I should have put smaller. Okay, if the top is smaller and the bottom is bigger, then the horizontal asymptote 100% of the time is y equals 0. Okay? If the top is smaller and the bottom is bigger, the degree, remember we're talking about the degree here, if that is the case, it's always equal to 0. What's the domain for this function though? So domain. Okay, domain for this function. Well, we have to keep into account these two things. The whole at -2 and the vertical asymptote at 4. So it's all real numbers except x equal -2 and 4. Okay, so remember, where the whole and the vertical asymptote occur, that's where our domain does not exist. Okay, why? These canceled. This is undefined. So those two things. And so if I was going to graph that here, this would be 4, and there would be a hole at -2. Okay? So let's do another example. Okay, so here's our example, x minus 2 over x squared minus x minus 2. And so the top is already factored. We don't have to do anything with that. The bottom we do need to factor. So what multiplies to -2 but adds to -1, I believe that would be +1 and -2. Okay, so what do you notice about the top and the bottom? They have a piece in common, so it cancels. What's left? If there's nothing left on top, we need to represent it with a 1, and we're left with x plus 1. Okay, so now I need to check all of those things I did before. First, let's look at holes. Okay, were there any common pieces in the numerator and the denominator? Yes, x minus 2. So how do I find the holes? I set that piece equal to 0. X minus 2 equals 0, x equals 2. Okay, now we need to look for vertical asymptote. Okay, vertical asymptote is the bottom once we've simplified. So I set this to 0, x equals what in this case? Well, x plus 1 equals 0, x equals -1. Lastly, horizontal asymptote. Okay, is the power of the top bigger or smaller than the bottom? Well, this is smaller than this, and so if you remember just a few seconds ago, if the top is smaller than the bottom, y always equals 0 for our horizontal asymptote. Okay, so now let's write up the domain. Domain is everything but these two things. So let's see, that would be all real numbers except x equal 2 and -1. Okay, there's the domain. And we'll go ahead and look at the range in this case. Range is everything but this horizontal asymptote. Now, I hesitate here because sometimes graphs cross horizontal asymptotes. They never cross vertical asymptotes. Occasionally they can cross a horizontal asymptote. Okay, so look at a graph to make sure, but in this case it's not going to, so it's all real numbers except y equal 0. Okay, and just to put this as a graph, I'll show you. Okay, it has a vertical asymptote at -1. Okay, it also has a horizontal asymptote at y equals 0. So I have my two pieces that are not going to cross. And then I'm going to plug in a number that's less than -1. So how about I plug in -2? -2 plus 1 is -1. 1 over 1 is -1. So that means -2, -1. So our graph does this and that. Okay, and if we want to plug 0 in just to show 0 plus 1 is 1 over 1 is +1, which is like right there. Okay, so you notice I'm not crossing this, I'm not crossing this, but I have a hole at 2. So right here I have a hole, 1, 2. And so this is how I take this information and graph it.